Hello everyone, so today in this video we'll be solving this question called sort colors, which is a medium difficulty level question and one of the most commonly asked questions by Microsoft as per Leetcode's company-wise question list. And if you're liking these videos, then please do consider subscribing to the channel and share it with your friends as well. And let's quickly move on to the explanation of the question as well as the coding part. Alright, so the question says, given an array with n objects colored red, white or blue, we have to sort them in place so that same color objects are adjacent. And red, white or blue, they are simply representing using three integers 0, 1 and 2. So there are two things. First, to be done in place, so no extra space should be used. And then here they've also mentioned that could you solve this problem without using a sort function, library sort function. So that is what we are going to aim for. We need to come with a one pass algorithm which is using constant space only. So this is the main gist of the problem that we'll be solving. And the input output test cases are pretty simple. It's an unsorted array and then it's sorted. That's it. So let's quickly move on to the visualization part and then we'll write the code. Alright, so let's move to the explanation part now. So we are given this array called nums and these are the values. We need to just sort them and return them. So this is the answer that we want to return. So all the zeros are together, then we have all the ones and then the twos. So for a brute force approach, you can simply sort the array. So we have functions, sorting functions, a lot of sorting algorithms as well. So you can use the inbuilt function for your language or any algorithm, and almost all of them have the fastest runtime complexity is n log n. So this is going to be your time complexity if you simply sort the array, and your space is going to be constant, or you might require some space depending on the algorithm if you're using merge sort or something. But other than sorting, you can also go for a different approach. For example, let's say something like a counting sort. So if you know what a counting sort is, so counting sort simply is not a comparison based but a frequency based sorting algorithm. So you can simply basically have three variables, let's say ones and twos and zeros. So you simply make a count of all the variables. So we have two zeros and two ones and two twos. So once you've iterated over all the elements, you've counted the elements, then you again iterate over the entire array and you can overwrite elements depending on the frequency. So first two elements, you write them as 0. Then the second two elements, you write them as 1, as many ones you have. And then the remaining elements, as many twos you have, you simply write them as 2. So this is going to take big O of n time only. And you will require two passes for this. First, when you store your counts, and then second pass when you update elements to the sorted order. So this is actually going to be big O of n plus big O of n. So it's asymptotically big O of n, but it's represented as big O of 2n because you're using two passes. So there is also a better approach which uses a single pass to do all the work. So let us discuss the most optimized approach for this particular question. And I've read on the elements in a bigger fashion to explain this better. So the algorithm that we're going to use is known as the Dutch national flag algorithm, Dutch national flag. And don't go over why it's called this particular name, but this is the algorithm that we are going to use. And this is also known as something like a three-way partitioning. So you must have heard these terms as well, three-way partition. So basically, whenever you have any given set of elements in which you need to make three partitions. So one partition for some logic, then another logic, then another logic. And this is how you want to sort them. So this algorithm can be used. For example, you want to sort three different numbers. And also if you want to have any like range-based sorting. So for example, you're given two numbers, let's say A and B. And you have to sort values such that all elements less than A lie in the first half. All elements in between A and B lie in the second half. And all elements more than B lie in the third half. So for any such questions in which you are required to split the array into three different sections, so this Dutch national flag algorithm, or also known as three-way partitioning algorithm, is going to come into the picture. So let me explain the algorithm. This works in linear time and is a pretty easy algorithm once you know how this is functioning. Alright, so what we'll do in the algorithm is we have three variables. We'll have low, we'll have mid, and we'll have high. So this is the basic pattern of this algorithm. The idea is these three values represent indices. And for example, the first set of values are from index 0 to low minus 1. This will contain the values, for example, in this case, this will contain zeros. Then the second values will be from low to mid. So this range will contain values, for example, in this case 1. And then the third will be from mid plus 1 to high. So this range will be containing values from the third nature, which is 2. So this is how we do this. Before we start, our low pointer points at the first element. So for example, this is where my low is currently. And my high points at the last element. So this is where my high is. And for mid is always going to represent the value which we are currently at. So since we'll be starting from the very first value, so mid will also be pointing to the first value in the beginning. But then mid will keep on moving ahead and will always represent our current value. And what we do is we are simply going to make some swaps between low, mid and high so that the correct value lies in its correct partition. So for example, current value for mid is 2 and 2 needs to lie in the half which is pointed to by high. So we'll simply swap values at mid and high. So this will become 2 and this will become the high value which is 0. And we will move high pointer backwards. Why? Because we already know that this value is in its correct half. And so we need to make changes to the remaining part. So we can make high to point to the previous value. But here for this swap, we won't be changing mid because mid has just received a value from high. And as of now, we are not sure what that value is. It can be 0, 1 or 2. So we will again have to check for that value in order to make some more swaps. So for example, in this case, we swapped 2 with 0 and we received 0. So again, we'll check for 0. So our current value pointed to by mid is 0. Since 0 lies in the first half pointed to by low, we'll swap it with low. So 0 gets swapped with 0. And now we'll move mid forward. Also, whenever we swap with low, we can move low forward as well, because we know that towards the left of this half, all the values are already arranged. Similarly, like we moved high towards the left, we move low towards the right. So low will also point to this value. Now current mid is this 0. So 0 already needs to be swapped with low. We will swap it with low, and then both mid and low move forward. So mid and low come here. Then current value pointed to by mid is 2. We will swap it with high because 2 needs to go to the right half. So this is where high points at. This will be 2, and then this will be 1, the value which high brings in. So once we have swapped, we will move high backwards. So high comes at this particular position. And now we won't move mid ahead because, as we discussed, we don't know what this value is. We will again need to check this. So now mid is pointing to 1. For 1, remember that mid is the one that corresponds to 1's partition. So we won't have to make any swaps in this case. We can simply move mid ahead because 1 needs to already belong in this partition only in which it currently is. So we will move mid ahead. Mid comes here. And now mid is equal to high. So once mid is equal to high, we know that there is no more swapping required because this is basically the boundary of the partition, right? And this is how we know once mid reaches high that we are done with this algorithm and we have made all necessary swaps. So let's see what our final contents of the array after all the swaps are. So at first position we have 0. Then here also we have 0. Here we have 1. Here also we have 1. Then here we have 2 and 2. So you can clearly see that this is one partition, this is the second partition, and this is the third partition. This is why it's known as three-way partitioning, and we have sorted all the elements, and this has been done in place. So the time for this is big O of n. And to talk about space, again, we are not using anything. So this is constant in terms of space. All we use is these three variables. So that is considered as constant space only. So this is linear time and constant space. And we did this entire thing using a single pass. And that is why it is known as one pass algorithm. Yeah, so this was all about our Dutch national flag or DNF algorithm. This is also known as DNF. And this is very handy whenever you need to make any three-way partitionings. So do remember this strategy, and let's move on to writing the coding part, which is going to be pretty easy in this case. Okay, so let's quickly get done with the coding part now. So this function accepts a vector or an array list in Java, which is called nums, and we just need to sort this in place. We are not required to return anything, and this will probably be called later on to check if this is sorted or not. So as we have already discussed in the explanation part, we are going to be using something known as the Dutch national flag algorithm to solve this question, and this is also known as something like three-way partitioning, which is really helpful whenever you have to solve anything required to partitioning an array in 3 ways. So what we'll do is we'll have three variables, the low, mid and high variable. Low will point to first index, mid will also point to the first index because that is where we are starting from, and high variable will point to the last value, which is nums.size -1. This is the index where it will be pointing at. Now what we'll do is we'll iterate over all the values until the mid and high indices do not overlap. So as long as mid is less than high, we will do this. What we'll do is we'll check the value at current mid index, which is always going to represent my current value. So this can be 0, 1 or 2. There are only 3 cases. So let's consider all the cases. If this is 0, then I will need to swap this value with my low pointer, which is where my 0 should be in the first partition. So I'll swap nums of mid with nums of low. And I'm using the C++ STL's sort function. If you're using Java, you will probably have to use an extra third variable to store the information as a temporary during swapping. And once we are done with the swaps, we will need to increment the indices. So low will get incremented. Also, mid will also get implemented because we are moving on to the next element. Now, if this was not 0, but if this was 1, let's say, so if nums of mid was 1, so for 1, as we have already discussed, we don't really need to make any changes, any swaps. We can simply move mid ahead. Otherwise, if this was nums of mid was 2, which is the only case left. So in this case, we will swap nums of mid with nums of high because this 2 belongs in the third partition in the right half. So we'll swap it with nums of high. And in this case, we will need to move high one position backwards, but we won't move mid because whatever we have received during this swap from high could be 0, 1 or 2, anything. And we will again need to check for that value at mid index. So we won't move mid, but we'll only decrement high because we know that 2 will always belong in the right half only. And yeah, once we're done with this, this will change all the values. So one thing that you need to make sure is I've always written else if, because once you are doing these swaps, you are again changing the positions of low and mid. So if you don't write else, it will again start another condition check from here itself, because at one particular iteration of this while loop, for one mid value, you will only run exactly one of these 3 conditions, not more than that. So that is why else condition needs to be mentioned, because these values are changing at every check. And once we're done with this, I think all values should be sorted. So let's run this. And it's working for the sample test cases. Let me submit this to check if this is getting accepted. And yeah, it's being accepted. So that's pretty much it for this question. This is only about the Dutch national flag, which you should be knowing. Otherwise, this is a pretty simple question. Yeah, if you like my videos, please consider subscribing and sharing it with your friends. Also, I have a Telegram channel as well, in which I keep sharing content related to interview preparation. So you can check that out. I've put all the links in the description itself. And if you have any suggestions or advice, please comment below and I'll be happy to read them. And thank you so much for watching. I'll see you very soon with the next question.